Hello guys, welcome to virtual lessons here. So for transition math, I guess I should say, I didn't write that up here, but hope you guys are doing well. Some of you guys might be enjoying the call, others of you might not like it very much, okay? But we'll have our lessons up here, and then as a reminder, okay, your parents know this especially, okay, because they got the email. If you have any questions that they can't help you with on Friday, I have a couple extra tutor sessions that you can attend as well on Friday, okay? So keep an eye out for that if you need to do that. Otherwise, we'll just go right into it. So we're going to start with lesson 69, okay? And lesson 69 goes over converting fractions to equivalent decimals. Okay, so um, we'll say fractions to decimals, fractions, which we've done actually before, right? Fractions to decimals. So if we're going to do this, right, let's remind ourselves of a couple things, right? We know about place value, right? We know about place value above 0. Right, we have like the ones place, the tens place, right? And I can keep going on and so forth, right? I have the hundreds place. And then over here, past the decimal point, I have the tenths place, right here. Not tens, but tenths with a THS at the end. And then over here, I have the hundredths place, right? And so on and so forth. And then the thousandths place. So that's something that will really help us, okay? Because if we have this example here, and I say, okay, I have example 1, and they said, right here, I want to express 2/5 as a decimal, right? Well, what you can probably see, right, I need to make my denominator a 10, 100, 1,000, right? If I can make those denominators, right, so I need to make, I guess I could write that, make the denominator a 10, 100, or 1,000, right, so I can see that and make denominator 10, 100, right, dot dot dot, so on and so forth, right? And that'll help me write as a fraction, or write the fraction as a decimal rather, right? So what I can do here is say, oh well, it's easy enough right here. I can expand my fraction. That's what we call this, right? Expanding my fraction, because 2/5, I can't change 2/5 to not be 2/5, right? So I have to say, okay, well, if I multiply the bottom by 2, I know that I'll get 10. Okay, and I have to multiply the top by 2, right? And you can see, right, if I was to cancel these out like normal fractions, when I go ahead and reduce, right, those would cancel out. So that's good because I know that 2 over 2 is really the number 1. So I'm not changing my fraction, I'm just expanding it. So I'll have 4 over 10, right? And then I can say, hey, you know what, that matches up exactly with what I see over there. So that's 0.4, okay? All right, and then next I have 9 over 20. Okay, 9 over 20. So I can go either way, right? I can go down or up in value. But typically when I have something like this, right, it's like, oh, well, if I went down in value, if I tried to make this denominator here, right, I'm trying to make it 10, I'm dividing my 9 there by half. I'd like to keep it whole numbers, okay? So here, I'm looking for denominator, right? I want the denominator to be 100. I can see that that's possible, right? Because if I did 5 here, I'd multiplied it by 5 on the top and the bottom, right? Again, I have to do 5 times 5 because that's the number 1. Then I'll get 45 here. So now that I have 100 for the denominator, right, I just go ahead and know, right, that I go ahead and fill in actually this 5 here, right? You know the 5 goes in the hundredths place, and then the 4 goes in the tenths place, okay? So you always start over here at the right side and fill them in, okay? So right here, right, then I'd say 0.45, or right, I'm starting with the 5, and then I go over that direction. All right, that doesn't look very explanatory, okay? 0.45. And then this last one, right, I have 59 over 250. Whoops, that's not 59. 59 over 250. So here, let's say, well, I can't go to 10 or 100, right? But I can go to 1,000, right? So let's go to 1,000 for my denominator. So if I want to do that, right, 250, I know that goes in, I just have to multiply that by 4. So 4 on the top and on the bottom. Okay, and if I do 4 times 59, okay, you should be getting better with, this head math here. But let's think about 4 times 60. What is 4 times 60? Well, 4 times 60 would be 240, right? Right? If you think about that, 4 times 60 would be 240. So if I think about how many times I'm multiplying 59, I'm multiplying it 4 times. That means I'm going to have 4 less than 240, which means I'll have 236. Okay? And I have 236. I know I start filling in my place values right from right over here, and then I go kind of that way. So I have 0.236 for my answer there. Okay, so there are my answers. Okay, and then the second option here, so that's my first kind of option there, right, is to just go ahead and change my denominators to be 10, 100, 1,000, right, knowing my place value. Well, sometimes it's not really possible. So I might have something like this where I have 3/8, right, and it might be possible I just have to pick a really big number, right? So then I got to remember and say, hey, what is that little, whoops, doesn't look very good. What is that little bar right there? What does that even mean? Well, that's a division bar, right? So it means divided. So I could write this another way, and I could say 3 divided by 8, right? Well, how could I write that a different way as well? Well, I could do 3 in this fraction thing, right? And then I could do 8, okay? Well, 8 doesn't go into 3, does it? No, it doesn't, right? But I know that I have a decimal after my 3, and then 3 is the same thing as 3.0. It's the same as 0, 0, right? And I can continue my zeros for as long as I want to, okay? So 8 does not go into 3, so I'll put 0 there. And then I know my decimal, okay? My decimal is right there, so it actually has to go in my final answer right there. So I'll leave it like that. And then 8 will go into 30. It'll go in 3 times. Okay, it'll go in 3 times. 8 times 3 is 24, so I put that here, and then I have to subtract it. And I'll have 6 here. I'll bring my 0 down, right? And then I have 8 times 7 would be 56. Okay, and this is just getting used to, multiplying these things in your head. Okay, and then I have 4, and then I can bring my 0 down, so now I have 40. So can 8 go into 40? Yeah, 8, 16, 24, 32, 40. So it's 5 times, right? And it's actually even number of times, right? So it's 40. So when I subtract this, I get 0. So once I get to the end, right, I know that I'm done here, right, because I have no remainder. So we'll talk about ones where you have just it keeps going on forever. Okay, that'll be our last example here in example 2, but this is example A, where it's fairly straightforward. You're going to get to an answer. Okay, now B. So B, we have 17 divided by 40. Okay, right, I can't go to 10 very easily. I can't go to 100. So I'm just going to go ahead and divide it. Okay, so I could go to 1,000. Okay, I could go to 1,000 if I wanted to. But I think I'm just going to go ahead and go here to the division. So 17 divided by 40. Okay, so it's important to you make sure you put your 17 in there first, right? Because 17, right, is smaller than 40, so you know that your number is going to be less than 1. Okay, so 17.000. And then let's start dividing, right? So this is all zeros here, 0, and then we have 4. 4 times 40 is 160, right? So I'll have 10 left over, and I can bring my 0 down. And I have 2, that's going to give me 80. Okay, I'll scroll down here. That's going to give me, subtracting, put that there, 20. And then I bring my other 0 down. Okay, important that you keep this lined up. And then 40. Does 40 go into 200? Yeah, right? 40, 120, 160, 200, right? So that was 5 times. So yes, 5 times 200 is an even number, or I'm not even number necessarily, right? It's even, okay, but it goes in an even number of times into my thing so that I end up with a remainder of 0. So that is my answer there. Okay, now this last example is a little tricky because this doesn't work out so neatly as these right here. Okay, so I have 5 divided by 6, or 5 6, right? So I have 5, and then I have divided by 6. Okay, so everything else looks normal here, right? And I'm just going to go ahead and start my problem. Okay, there's nothing different about how I'm starting this problem. But now I say, okay, 6 isn't going to 5, so that's 0. Okay, that's easy enough. Then I point. And then 6 will go in 8 times to 50, right? Because 8 times 6 is 48. And then I'll subtract it, and I'll get 2. And I'll bring my 0 down. Okay, I'm just going to go through this fairly quickly. You guys know what's happening, right? I say, does 6 go into 20? Yeah, it does, right? It goes in 3 times. So 3 times. And then that's 18. And then I go ahead and get my remainder again, right? That's going to be remainder 2. Okay, and then I have 20. That's going to be 3. Okay, and then I'll have 18 again. You guys see with the pattern here, right? I'm going to get 2 here. Then I can add another 0. And that's going to bring another 0. I'm going to keep getting 3 here for my numbers after my 0.8, right? It's going to be 0.83333, right? I'm going to keep writing 3. Right, I think you guys can see that. So what I have to do is figure out how I'm going to write that, because I don't want to write 3's forever, right? So what I'm going to write here instead, I'm going to write 0.83, okay? And then there's this horizontal bar here that I put above my 3. And this horizontal bar just means that my 3 keeps going on for forever, okay? So I don't have to write it there. Like I did in the green, I just go ahead and write my vertical bar, and that means that my answer is 0.83, and then it keeps repeating. Okay, so this is my, well, maybe I don't want to do a green because, okay, but 0.83 is my final answer here. Okay. All right, so if you want to go ahead and look at your practice problems there, or not your practice problems, but your built-in skills rather. And you can come back and we'll be on lesson 70. So you can pause the video, come back, we're going to lesson 70. Okay, so lesson 70 here, we're going to compare fractions. So we've compared numbers before, right? So lesson 70, and comparing numbers is pretty straightforward, right? Let's see, lesson 70. Comparing fractions, though, is a little bit trickier. It's not really that bad, okay, but comparing fractions. So if I was comparing numbers, so let's just go back to numbers, right, and say, okay, well, if I have 3 and then I have 5, I usually just put this, this thing in the middle, right? We call it an inequality, but this alligator mouth sort of looking thing, and say, hey, 5 is bigger, right? And then we're done. Okay, well, with fractions, it's a little bit different, but we can just make sure, right? So let's go ahead and write an example, and then we'll talk about how to do it. And I can write a couple steps. So example 1 here, we have 3/7 and we have 5/11. Okay. Well, the problem here, right, is that I don't know exactly, right? I don't know exactly if they're the same because my denominators are different here. So my denominators are different. I'd like to make my denominators the same. So there's a couple different ways I could do that, okay? We could find what's known as the least common multiple, right? We've talked about LCM before, right? We could do LCM, that's one option, right? And then the other option is just to multiply. Okay, well, this is the other option. Multiply by the other's denominator to get the same denominator. Okay, and I guess what I should have said here, right? Um, I need my goal here, right, is actually to get the same denominator, right? So maybe I'll write my goal. Right, so goal, right, get the same denominators. Okay, I'm gonna get the same denominator for both of these. So if I think about these and say, oh, okay, well, if I go ahead and say, hey, let's multiply by the other's denominator, right, and this is actually a fill-in sort of thing. I want to put my inequality here in the middle, right? So I could put something like this, or I could put something like that, but I don't know if that's going to be correct yet. So let's follow my step here, right? I just kind of told you that, right? But if I did 11 over 11, right, then on this side I have to do 7 over 7, right? So if I did that, what would I get for my final answer here? Well, this fraction would turn into 33 over 77, and this other one would turn into 35 over 77. Okay, so you see what happened there, right? I just multiplied by the other's, I guess I should have put an apostrophe here, other's denominator. And now I can see, right? Now I can put my inequality and say, hey, you know what? That one's bigger. Perfect. Okay. So now let's look and see how it works with another one. This is part A. Let's look at part B. So part B, I have 9 over 10, and I have 13 over 14. So, like I said, the other way I could do this is just find the least common multiple, okay? Which I could do here. Let's go ahead and do that too, right? So we could say, hey, let's find the least common multiple. Let's use that ladder method that we talked about. 10 and 14, right? What number goes into 10 and 14, right? Well, 2, right? So you say 2 and 5 and 7. All right, and then any other number besides 1 go into all of these numbers? Hopefully you can see nothing does, right? Actually, here, I'll do a different way to circle it. This is that ladder method, or you say it's the L method, okay? 2, 5, and 7. So if I multiply 2, so if I do 2 times 5 times 7, I'll get 70, right? So 70 is my least common multiple for those denominators, right? So if I want this to be 70, I say, hey, let's multiply this by 7 over 7, right? And then this one over here, what do I have to do? Well, it's a little bit harder to see, right? But I go ahead and we could find out, right? We just say 14, and then the next multiple of 14 is 28, 42, 56, 70, okay? It's going to be 5, okay? 5 over 5, right? And you can see right here, what am I multiplying my fractions by? Let's go back to this one up here, right? I multiplied 3/7 by 11 over 11. So what is 11 over 11? Well, 11 over 11 is just the number 1, right? And same thing with the other one. 5 over 11 multiplied by 7 over 7. I'm just multiplying it by the number 1. It just looks a little different. Okay, so now you can see here, right? 9 times 7, I'd have 63 over 70. Here I'd have 13 times 5, right? So 13 times 5, okay. So 26, 52, 65. I actually have 65. Okay. You might have to write this out on the side. Don't worry about that, right? Go ahead and do that. Take your time. And then I get this inequality with a mouth facing to the right direction. Okay. last one here for example 1. So I'd have 11 over 15, and this would be 7 over 10. Okay, so for this one, I could do the ladder method again, right? Or I could say, hey, you know what? I start with the biggest denominator. So my biggest denominator is 15. 10 doesn't go into 15. But if I do 15 plus 15, I get 30, right? So I'll get 30, and 10 we know goes into 30, right? Ends into 0. So I already figured it out just kind of by thinking about it in my head, right? So I say, okay, well that means I'm multiplying this by 2 over 2, right? So that means this one over here I'd multiply it by 3 over 3, okay? And then I'd have 22 over 30, and then over here I have 21 over 30. So then I put my symbol in here, right, and say, oh, this one goes to the left like that. All right, so let's go ahead and go to example 2. So I could change, right, so example 2, I could change my fractions to decimals, right? So that's my second option, right? So change fractions to decimals. Okay, that's an option. So we just learned how to do that, right? So we just did 5/6, and we have 4/5. Okay, well, when I changed my 5/6, you guys might not remember, right? But I did 5 divided by 6, right? And you guys remember what I got? I got 0.83 repeating, okay? So I went ahead and did that right here, right? So I did this, and then I end up getting my answer, right? 0.83, and then it started repeating, okay? So that's my answer for that side, right? And then if I think about 4/5, I'm going to change that to a decimal. Well, I could do it a couple different ways, right? If I said, hey, let's multiply this by 2 over 2, right? Then I know that this is just going to be 8 over 10, right? 8 over 10 is just 0.8, right? Then I say, oh, 0.8, so that means, right, if I'm going to put my mouth in here, it's going to go to the left. Okay, so that was part A of that example. Part B, okay, let's just go ahead and do this one real quick too. We have 7 over 20, and then we have 4 over 11. So this one on the left side is really easy to change because what I see right now, hope you guys see it too, right? Start noticing these things, right? Try to notice them, I guess, more deliberately, right? I can multiply this by 5 on the top and 5 on the bottom, right? And then I'll get 35 over 100. And 35 over 100, right, is 0.35, okay? And then 4 divided by 11, okay? So this right here, remember, that's a division sign, right? So then I say, okay, 4 divided by 11, okay, 0, 0, 0. So 11 doesn't go into 4, so that means that I'll have a 0 here, so 0 point, and then I have 3. Okay, so that's on the same spot here, right? 3, and I have 33. And I'm going to subtract, so I have 7, and bring my 0 down. That's going to be 6. Okay, so 6, and then I can go ahead and say, okay, well, that's going to be 4, 0, okay. But when I do this, right, what do I notice? Well, I'm already at 0.36 anyway, right? So if I'm already at 0.36, I know that I'm going to have a bigger number than I had over there, right? So I can just kind of stop right there, but let's go ahead and actually do one more here, right? So then I have 11, going into 40, right? That's going to be 3 times. Okay, that's going to be 33. Then I'll have 7. I can bring my other 0 down here. If I have a 0 and I bring it down. But you can see here, what am I going to get next? I'll actually have another 6. Okay, so I have 3, 6, 3, 6, and it's going to keep on repeating like that. So when that happens, right, last time I had 0.083, so this one up here, I'll put in green here, 0.083, and that 3 was repeating. Well, in this case, both my 3, 6, both my 3 and my 6 are repeating, right? So it's 3, 6, 3, 6. So in this case, I would just write my final answer here, and I just say 0.36, and then I'd put the repeating over both of my numbers there, okay? All right, so now I can go ahead and fill in what's going to happen here, right? My mouth is going to face to the right. Okay, and last but not least here, right, we have C. So for C, I have 10 over 13, and then I have 7 over 9. Okay, so if I have 10 over 13, let's see here. I'm trying to think if I could change the denominator to 100,000. I can't think of anything right this second. Okay. I think it could go into 1,000, but anyway, we'll go ahead and do it the normal way, right? 10 should be let's see, would it work? I'm trying to think. Okay, anyway, 10, and we'll divide it by 13. Okay, these are these might take a little while. Okay, so it's okay. But let's go ahead and do these side by side. So 7, and then we're going to divide it by 9. Maybe we'll see something when we do them side by side. So they're both going to be 0, and then 13 will go into 100. How many times? Let's see here. Let's think about that. I think it's going to be 7. Okay, so 7, and 7. So it'll be 10 times 7. That'll be 70. Then so it should be 91. And I'll have 9, and then I'll have a 0 to bring down. So I'll have 6 here, right? And I'll have 6. So that means I'll have 78. And I'll subtract, and I'll have 2. Not 2, 12. 120. Okay? 120. So 120. And then if I have 9, 9, 9 times 13, right? That'll be 9, 3, 27. Okay, right? These are a little bit big numbers, but I go ahead and subtract it, and I know I have 3 there. Okay, we'll stop right here for a second, okay, and then we'll start on my other problem. So we'll bring this 3 down. And then for this one over here, 7 divided by 9, okay? Right, that's what we had up here. Okay, so we have part of our answer here. Now we can say 9 is going to 7, right? That's 0. 9 goes into 70. Let's see. Well, 9 times 6 would be 54. 9 times 7 is 63. So it's 7 as well. So I'm kind of stuck in the same spot. I need to keep going to figure out my next one. So subtract, and I'll get 7. I can bring my 0 down. Okay. Oh, look, I have another 7. 70, right? So that means I'll have another 7, right? Well, at this point, right, I can actually look at my numbers now, right? Do you see the numbers, right? I can look at the numbers and I can say, hey, this one on the right side is bigger, right? So I can actually just stop right here and I can just go ahead and put my sign there, or symbol. Okay, so that finishes up that lesson. So let's go ahead and look at 71. So we're halfway through here. So 71, got fractions worth 1, and then we're calling complementary fractions. So fractions worth 1, I think you guys, we've talked about this before, okay, but fractions worth 1, okay, and this is the number 1 here, right? It's not like an I. Worth 1, oopsie, I messed up something here. 1, and complementary fractions. Okay, so complementary fractions, right? You get, I think you guys know what fractions are. Let's go ahead and cover them in that order, okay? But example 1 here is have a couple examples, right? If I have any number and this number on the top and the bottom are the same, right? Then I just have a fraction that's worth 1, right? So that's going to be 1. If I have 9 over 9, right? I'll have 1. And so on and so forth. 29 over 9, right? This almost seems too simple to write, but at the same time, right, it's just important to make sure we review this and understand this fact, right? And even if I write a decimal, let's just say I wrote a decimal and I write 13.5 over 13.5, that's also going to be equal to 1, okay? Same number on the top, same number on the top, on the bottom, right? It's going to be equal to 1. All right, now let's talk about complementary fractions. This is example 2. So complementary, it's just basically two sides or two parts to make 1, right? So they always add to 1. They add to 1, okay, as I set up above, right? So if I was going to talk about 3/8, and I said, hey, I have 3/8. What is 3/8 complementary fraction, right? And I said, hey, what's complementary fraction? We're going to use C to represent that. They say, oh, well, 3/8 complementary fraction, right? Would just be the other side to that, right? And be like, oh, well, then it's just 5/8, right? Because if I add those things up, right? So if I add these, right? What am I going to get? I'm going to get 8 over 8, right? If I add those, okay? So same thing if I had 5 over 11, okay? And I said, hey, what's the complementary fraction for 5 over 11? And hey, that's just 6 over 11. I'm just completing those up, right? Because then when I add these up, then I'll get 11 over 11, so on and so forth, right? Now the right, if I had half, right? So if I had 5 over 10, right, which is half, okay? And then I said, what's the complementary form of that? It's just 5, whoops, I'm going to stick to my color convention here. It's just 5 over 10, and then I get 1, right? Okay, so I say 1, right? But I'm getting 11 over 11. This is all equal to 1, right? You guys see that? So let's talk about if I had 6 over 6. So if I said, hey, I have 6 over 6, what is its complementary fraction? Okay, that's a little bit of a trick question, okay? But we're just trying to get you to understand, right? Then it basically, it doesn't have one, or you can say that its complementary fraction is 0 over 6, right? Because if you add those two up, you get the number 1. Or you can write it, right? You can get 6 over 6. Okay, same thing with this one over here, right? You get 10 over 10. Okay, so if I go to our last example here, and say, hey, let's look at example 3. And let's say I have some animals, right? And I have 3/7 of my field is, I don't know, goats or something, right? Whoops, I didn't write that very well. Goats. 3/7 is goats. And my field only has, sheep and goats. Okay, I'm just gonna say this, right? It says sheep and goats. So if I have sheep and goats, and you say, oh, you know what? I can use my complementary fraction here, right? And I say, hey, well, if there's 3/7 goats, then, right, I can say, well, the complementary fraction of 3/7 is 4/7. So that means that 4/7 of my field is sheep. Okay, so hopefully you see how that works there. Okay, right? If a field only has sheep or goats, 3/7 of the field is filled with goats. Or you could even say it this way, right? You could say, hey, I have 3 goats and there's 7 total animals, right? What if I said that, right? And then I'd say, hey, this is the number of animals total, right? And then this top number is my goats. Then you can see how that would work out, I think. Okay. All right. So going to work through those building skills. Let me know if you have any questions, and then you can go on to the next lesson when you finish with those building skills. We're going to our last lesson here. Okay. So 62, or not 62, 72. So lesson 72 is about percentages. So we talked about percentages a little while ago, right? And we said, yeah, percentages, right? They're fairly straightforward in one way, right? We see them all the time at the store, right? Say save 10% or whatever, right? But if I want to change a decimal to a percent, right? So decimal to a percent, what do I have to do? Well, I just simply, right, this is all I do. I just move the decimal 2 places to the right. Okay, and I think we talked about this a little bit, right? Or at least I like to bring it up. Okay, just to remember that we have like a reference, right? And say, hey, what if I ate 1 pizza, right? If I ate 1 pizza, right, and say if I ate 1 pizza, right, and I said, how much in percentage terms, how much did I eat of the pizza? And you say, hey, you ate 100% of the pizza. Well, let's look and see what really happened here, right? And my 1 pizza, where was my decimal place? Well, it was hiding back over there, right? It didn't write it. And then where's my decimal place now? It's at the end right there, right? It just moved over 2 places. Okay, so same thing, right? If I have an example, so let's go to example 1. I have 0.71. I want to change that to a percent. I'm just moving over 2, right? And then it's just 71%. Okay, same thing, right? This is A, and then there's a B, and there's a C part. Okay, as you're following along here. So if I have 0.15, and I just go ahead and move it over 2, I have 15%. And my C, I have 0.07, right? So then when I move it over 2 places here, I actually only get 7%. So a little bit different way to look at that, and then, or a little bit different than the other one, right? Because I'm not ending up with 2 numbers in my final answer. And right, you can work with really small percentages besides just 7%. Okay, but D, I have 0.4. Okay, so 0.4, right? I don't show the other 0 back here, right? Because there's another 0 hiding back here, but it didn't show me. So it's hiding there. So then when I go ahead and look at my final answer, right, it's 40% or 40%. Okay, and then E, I have 1.26. All right, so don't let this trip you up, right? I have 1.26. It's still moving 2 places to the right, and so then I have a percent that's greater than 100%, right? It's 126%. And even more, right? If I have something like F, where I have 3.8, right? If I have 3.8, and I want to convert that to a percent, I go ahead and say 380%. All right, so that's really important that we know how to change them to percentages that way. And right, if we go backwards, there's nothing really to it, right? If I'm going to go backwards, like I said, I like to keep this example kind of in your head, right? If you think about this one, going back and forth is easy, right? Because I was like, okay, well, it's one pizza, it's 100%, right? So I can go back and forth really easy. Okay. So then if I'm just working with whole numbers, right? So example two just is dealing with whole numbers. I don't think I need to say much more, right? But if I have example two and I have the number two, well, with the number two, where is the decimal place? Well, it's right there, right? So I'm doing the exact same thing, right? I'm moving the decimal places two places to the left, or not to the left, but to the right rather, sorry, to the right. Just like I did up here, right, with 1, right? I moved it over there. So if I'm going to change this one, right, then it's going to be 200%. And then same thing, right, if I have B, B is 8, so 8 is just going to be 800%. Another way you could say this, right, is that I'm putting 2 zeros at the end when I have a whole number, okay? Last one here, or last two, I have 12, okay? Then I'll have 1200%, so it's huge percent change. And then last one here, I already did this one up above, 1, I'd have 100%. Okay, and I think that completes it, so I don't think there's anything I want to say here. But you do notice, right, when I have a whole number, right, all that's happening is I'm getting 2 zeros at the end of my answer there, okay? And then, going backwards, we're going to go over that as we go through this as well, right? We're just going to go backwards if we want to change our percents to decimals, right? We just go ahead and move, instead of moving our decimal place, right? So I said move the decimal 2 places to the right. We're just going to move them 2 places to the left, okay? And always keeping in mind what? Because you remember this, right? Always keeping in mind that we're in this place value sort of realm, right? This is the ones place, the tens place, and then when we're over here, we're in the tenths place, right? This is this place. Then over here, we're in the hundreds place, so on and so forth, right? So if I wanted to write this any other way, right? I could write these any other ones, right? So if I want to change 100% back to a fraction, right? Well, I just say, hey, let's put 100 over 100, right? That's one way to change it back. And then we could just keep it like that, or it's just going to be the number 1. So it's really simplistic there, but that's one way we could show it there, is just putting our percent over 100, because that's what percent really is in the first place, okay? It's just a way of more easily communicating numbers versus just having to say fractions all the time, okay? So hope that was helpful. Let me know if you have any questions over anything. Attend the Friday session if you need to, and I'll see you guys next week, Lord willing. Okay, bye.